So section 12.3 has got the best of both worlds for you. Not only do you get to solve a 3x3 system equations, but you get to come up with that system yourself. You have to figure out what that is. So this is the application section that usually follows the introduction of something new. So the big battle for you, I think, in most of these cases is going to be coming up with the system of equations. So let's take a look at this. This is actually an improved problem from previous editions. In previous editions, this nutritional planning problem, they wanted you to create a diet based on foods A, B, and C that had, like 5 grams of carbohydrate, 5 grams of protein, and 10 grams of fat, which made no sense nutritionally, but let's not worry about that. We want to create a menu that's going to supply us with the following nutritional values. We want 22 milligrams of niacin, 12 milligrams of zinc, and 20 milligrams of vitamin C. So pretty heavy on the vitamin C, but that's okay. How are we going to get that? Well, these different foods, A, B, and C, supply various amounts of these nutrients. Food A gives you 1 milligram of niacin, 1 of zinc, 1 of vitamin C, etc. So these are all our unknowns. We don't know how much of food A, how much of food B, and how much of food C we're going to need for each of these. So let's see if we can't figure out a system of equations for this. So the first equation that we can get is based on how much niacin we need. We need 22 milligrams of niacin. So where are we getting our niacin? Well, so for our niacin, we get 1 milligram from A. So 1 times A plus 2 times B. And let me zoom out a little bit here. Plus 2 times B, plus 2 times C, and the total of this, 1 times A plus 2 times B plus 2 times C, should be the 22 milligrams that we're looking for. So that's one equation. But that one equation has 3 unknowns. Typically speaking, if you want to solve an equation with 3 unknowns, you'd like 3 equations. So I need 2 more equations. But can you see how we get the next one? We get the next one based on zinc. What would the next equation look like? Yeah. 1 times A plus 1 times B plus 1 times C equals 12. You don't have to put the 1 here. I'm doing that just to try and emphasize where this is coming from. It's this number times A, this number times A, or this number times B, and this one times C, etc. Now there's one last equation that we need here, and that's for the 20 milligrams of vitamin C. See if you can't write down that 20 milligrams for vitamin C. Tracy, what would that last equation be? Perfect. So that's your system of equations. Most likely what I'm going to do on the test for problems from this section is just ask you to set up the equations. The reason for that is because I don't want you to go ahead and solve it, because if you make a mistake setting it up, then you're obviously going to get the solving it part wrong. So I'm going to try and minimize the damage there. These are going to be kind of standalone problems. Set them up. But the setup is important. My feeling about this is kind of evolved over the years. I mean, you can Google your answers to just about anything in this class. The important thing, though, is are you Googling the right question? Are you setting it up correctly? I mean, you can get the answer to anything, but you have to ask the right question. So I want to see if you're able to do that. Here's our system of equations. Let's practice solving this with an inverse matrix. Okay, so this is more practice from section 12.4. Are you comfortable though with the setup of this thing, where that one comes from? So if you're not, then please get some help. Let's solve this with an inverse matrix then. So this is review for you from section 12.4. This system of equations is going to be based off of the coefficients. So I'm going to call matrix A, and I know I've got A in the problem, I'm sorry. Matrix A is going to be 1, 2, 2, 1, 1, 1, 2, 1, and 2. And just like matrix A is already in the problem, I know matrix B is in the problem. We'll deal with it. What do you think B is going to equal? Anyone? Good. 22, 12, and 20. We want to enter these into our calculator and then calculate our solution as being A inverse times B. So that's what we need from our calculator. So copy that down, and let's get busy putting these into our calculator. We're going to put this into our calculator much like we did for Cramer's rule. So hit the second key, then the X inverse key. We want to edit matrix A, so cursor over to edit. Select matrix A, it's a 3 by 3. And let's enter those values. So 1, 2, 2, 1, 1, 1, 2, 1, 2. When you get that, exit out of here. Press the second key, then the mode key to quit. Then we're going to go right back in and enter matrix B. So second matrix. This time we're going to edit matrix B. What's the dimensions of matrix B? 3 by 1. 3 rows, 1 column. So 3 by 1. Now I want you to enter in 22, 12, and 20. So there's matrix B. When you have that entered in, again, second, and then the mode key to quit. If you're unsure of yourself, you can press second and then X inverse again and type out the matrices. Just make sure that you entered them correctly. There's nothing wrong with that. If you're pretty confident, then you can skip this step. Let me clear that out. I need to calculate A inverse times B. So the first thing to do is to type matrix A. Second, then the matrix button, and press enter. Don't press enter twice. I only want it once. How do I get the inverse? Remember that? Yeah, the inverse button. Let's just press that right there. A inverse times matrix B. So go back to the matrix menu, cursor down to the second one, and press enter, or not, just type the number 2. There you go. A inverse times B gives me 2, 4, and 6. That's going to be A, B, and C relative to the problem right there. 2, 4, and 6. So 2, 4, and 6. So I need 2 servings of A, and then let's see, 4 servings of B, or 4 ounces of B. And finally, 6 ounces of C. Okay, done. The important part was the setup of the equations. Are you okay with that setup there? Let's try another one. Problem number 28. Now, I don't think it's going to surprise anybody that if you have 2 points determine a line. So if I draw any 2 points, I can determine a line. But what would happen if I had 3 points? What do 3 points determine? 3 points determine a parabola. And the general equation of a parabola is this: y equals ax squared plus bx plus c. So let's take a look at problem number 28. In problem number 28, we've got a parabola that passes through 3 points in particular. Passes through, passes through these 3 points. What we could and should be able to do with our system of equations is to set up a system of equations that will allow us to solve for A, B, and C. That is, to figure out what the equation of this parabola is. So let's see how that's done. So my general equation for a parabola, and once again let me write it up here, y equals ax squared plus bx plus c. I've got several points. I've got 3 points that satisfy that equation. I've got the point -1, -3, 1 and -1, and 3 and -7. All 3 points of these fit on my parabola. What I need to do is figure out what kind of an equation that gives me. Let's keep in mind that this is your x-coordinate and this is your y-coordinate. And if this is a point on the parabola, then it fits in this equation. I can plug it in. And let's do that. So if I plug this in to this equation, it would look like this. -3 equals a times -1 squared plus b times -1 plus c. So that's the first equation I get. What about the second equation? Anyone want to try the second equation? Kiana? What would the second equation look like, please? Start with y. -1 equals Cool. So again, just plugging things in. You're plugging in your x and your y. Vincent, how about the last one here? What would the last equation look like? Squared. Perfect. It's probably in your best interest to clean this up. Thanks, Vincent. So let me clean up this equation. This first one is -3 equals, well, what happens when I square -1? It becomes +1. So it's going to be a, what's the middle term going to be? Minus b plus c. And then -1 is a plus b plus c. And then -7 equals, so I want to do the last one. Patrick, thanks for volunteering. Thank you. 9a plus 3b plus c. Perfect. So that's your system of equations. You can plug that into your graphing calculator. You can solve it with Cramer's rule. You can graph it. That'd be tough, really. Addition, substitution, Gaussian elimination, reduced row echelon form, all kinds of different things. All right. But probably your graphing calculator would be a really good place to start. And when you solve that, you get A is -1, B is 1, and C is -1. Let's understand what that means. What that means is you can put that in this equation. We get y equals -x squared plus x minus 1. Yeah. That's the equation that passes through those three particular points. Yay. Okay. Are you comfortable with those two examples? All right, I'll give you a few problems in homework. Remember, you got a test on Monday.